here we have the function of a vector field. A equals 4x squared yz squared in the I direction minus xyz in the j direction plus x squared y cubed z cubed in the k direction. You must find div A, that's the divergence of A, and the curl of A. Now, I'm going to ask you to write this down. Pause the video, write it down, and then work out both of them before you continue watching the video. Okay, are you finished? You found divergence. Now let us look at what this is about. So we're doing part A now. Divergence A. Remember now, the divergence is going to be the gradient vector dot A, the dot product between grad, which we call nabla or del, and A. So nabla is the partial by partial x in the I direction plus partial by partial y in the j direction plus partial by partial z in the k direction. So it has to be partial of something. We're going to find out what. Dot and A. Remember, generally we said it was axi, but we have the function. We know what ax is. Ax is 4x squared yz squared. Then we have I minus ay would be xyz. That's j plus, and az would be our x squared y cubed z cubed k. So remember, when we're looking at it, we generally wrote the vectors axi plus ayj plus azk. It was vector A. Here we see what ax is, what ay is, what aj is. Alright? Now, nabla dot A is going to be, remember when you find the dot product of two vectors, is going to be just coefficient of I times coefficient of I plus coefficient of j times coefficient of j plus coefficient of k times coefficient of k. So it's going to be the partial by partial x of 4x squared yz squared plus the partial by partial y of negative xyz. There's no j, no directions, it's going to be a scalar. Then the partial by partial z of, and we have our x squared y cubed z squared. Good. So we have that. So the divergence is, when you differentiate with respect to x, we have 2 4s 8, 8x yz squared plus differentiate, well, it's going to be a minus. Differentiate this with respect to y, we have xz, and plus differentiate this with respect to z, we have 2x squared y cubed z. So there we have our divergence. All right. Now, the next thing will be the curl of A. So part B is going to be the curl. Now, here, the curl will be the cross product now. It's going to be nabla cross A equals. Now, these are two vectors. We're going to find the thing there, the cross product of these two vectors, nabla cross A. In both vectors, we have the direction I, J, and K. And as you remember, in row 1, we have the I, J, K. Good. Then, in row 2, we'll have the coefficients of I, J, and K taken from the one on the left. These coefficients are delta by delta x, delta by delta y, delta by delta z. So let's put those in. Delta by delta x, delta by delta y, delta by delta z. Then in row 3, we have the coefficient of the directions I, J, and K taken from the vector on the right. So these are 4x squared y z squared, right? 4x squared y z squared. 4x squared y z squared for this one. Then negative xyz, negative xyz, and then the other one here, x squared y cubed z squared, x squared y cubed z squared. Alright, good. So this is going to be our determinant. So the curl is going to be I times the determinant. When you cover the rows and columns with O, you're going to have partial by partial y, partial by partial z of negative x, y, z, x squared, y cubed, z squared. So there you have that. Right. Minus j times a certain determinant. You will cover up the rows and column with j. So what you're going to have is partial by partial x, partial by partial z, 4x squared yz squared, and x squared y cubed z squared. Plus k now, and you have when you cover the rows and column with k, you will see these, so they will go in the determinant. So partial by partial x, partial by partial y, partial by partial x, partial by partial y, and 4x squared yz squared, 4x squared yz squared, and then we have negative xyz, negative xyz. Good. So then, here now, nabla cross A equals I times, it's going to be partial by partial y of x squared y cubed z squared minus partial by partial z of negative xyz. See that? Minus j times partial by partial x of x squared y cubed z squared minus partial by partial z of 4x squared yz squared. You can see it there. Plus k times, and this determinant is the partial by partial x of negative x y z minus partial by partial y of 4x squared yz squared. Okay. And then we say Nabra cross A, which is the curl, is I times. Alright. Now when you differentiate with respect to y, you get 3x squared y squared z squared minus, well, minus negative is going to be a plus. You differentiate it with respect to z, you get xy. Okay? Although you normally put the I after, so let's put the I behind here. Is this I, alright, minus something here, j. Let's assume it will end here and the j will come here. So the partial by partial x of this function is going to be 2x y cubed z squared minus, and the partial by partial z of this will be 4 2's 8 x squared y z. Alright, and that j so we have that plus k now. Now let's put the k after. So partial by partial x of this is negative yz minus the partial by partial y of this is going to be 4x squared z squared k. So there we have that. Now if we were given a set of coordinates, then we would put those numbers in it, right? But what we did was to find the divergence of A and then the curl of A. Okay, so I'll see you in the next video then.